Hello and welcome back to the Math Avenue podcast. I'm your host, Rolando ASISTEN Jr., and you're tuning in to episode 5 of our special series, Demystifying the 17 Key Algorithms Behind AI and Data Science. Now, if you've been following along, you'll know we recently made a big change. In episode 3, we covered the first 7 supervised learning algorithms in one sitting, but we heard your feedback. It was just too much to digest at once. So starting in episode 4, we decided to take it slow, one algorithm per episode. And in episode 4, we talked about k-means clustering, the first algorithm under unsupervised learning. Today, we continue with algorithm number 9, hierarchical clustering. But first, let's remind ourselves what unsupervised learning is all about. Segment 1. What is unsupervised learning? Unsupervised learning happens when machines are given no labels and no answers. It's like giving a toddler a box of completely mixed toys, no instructions, and asking, "Can you sort these out based on what you think goes together?" That's the spirit of clustering, letting the machine find hidden patterns and similarities all on its own. Analogy: the tidy drawer. Imagine opening your junk drawer at home. It's full of random things: pens, screws, rubber bands, receipts, paper clips. You start sorting them by what they are. Paper clips go together, pens go together, and so on. You're grouping them based on similarity, starting small and building up. That's what agglomerative hierarchical clustering does. You start with individual items and slowly merge them into bigger clusters. Or flip it around, start with a full drawer and break it apart layer by layer into more specific groups. That's divisive hierarchical clustering. Both approaches build a tree-like structure called a dendrogram that shows the relationships between all the items. The concept goes back to the 1960s, thanks to researchers like Robert Ferris and Lance Williams. But really, humans have been thinking hierarchically for centuries. Remember Linnaeus, the guy who created kingdom, phylum, class, and so on to classify animals? That's hierarchical thinking, breaking things down into nested categories. How it works in plain English. You start by treating each data point as its own cluster. Then the algorithm finds the two that are closest together and merges them. It repeats that process, step by step, until everything is one big group, or until you choose to stop. The result is a visual map showing which things are most alike. You can decide how many groups you want just by slicing the tree at a certain height. It's flexible, intuitive, and you don't even need to guess how many clusters you want at the beginning. Let's do a quick showdown. K-means versus hierarchical clustering. K-means is like your efficient friend who organizes stuff fast, great with big data, but needs to know how many boxes to use. And if you give it weird-shaped stuff, it gets confused. Hierarchical clustering, that's your artsy cousin. No need to say how many groups, you just watch as it builds a beautiful tree of relationships. Super insightful, but kinda slow and moody. One small change in the data, and the whole family tree shifts. So, if you're in a rush, go with k-means. But if you want depth and drama, hierarchical clustering's your pick. Let's look at how this algorithm works in the real world. First, museum curation. Museums use it to group artworks by style, era, or artist, allowing curators to design themed exhibits that make sense together. Second, genomic research. Scientists use it to analyze genetic patterns, finding relationships between species or identifying genes linked to diseases. 3. Airline pricing. Airlines cluster travelers based on booking behavior, like how early you buy, your destination, or seat preferences, to tailor personalized promotions or dynamic pricing. Fourth, social media content discovery. Platforms like YouTube use it to group content creators. So if you like one cooking channel, it recommends others with a similar style or tone. 5. News aggregation. It helps cluster articles that are covering the same topic, even if they use different keywords or writing styles. 6. Marketing and customer segmentation. Companies analyze purchase history to group customers into personas, like bargain hunters, luxury shoppers, or eco-conscious consumers. 7th, academic research classification. Universities use it to cluster research papers or topics, making it easier to organize libraries and discover new areas of study. Segment 7. Strengths and limitations. So why use hierarchical clustering? Because it gives a full picture of the data, showing relationships at every level. And you don't have to pick the number of groups ahead of time. But it's not perfect. It can be sensitive to noise or outliers, and it can struggle with very large datasets. Still, when used wisely, it's one of the most powerful tools for exploring structure in data. So there you have it. Hierarchical clustering, the 9th algorithm in our series. It helps bring clarity to chaos by organizing data in layers, just like we organize ideas, family trees, or even bookshelves. In our next episode, we'll tackle DBScan, another powerful clustering method. Great for when your data has noise and odd-shaped patterns. And don't forget, if you've been enjoying this series, my books They Saw, What Others Couldn't and What Faith Looks Like are now available on Amazon in Kindle and paperback. What Faith Looks Like is also available in audiobook format on Spotify, Google Audiobooks, and more. Your support helps us fund scholarships and expand learning for students around the world. Thanks for being part of that mission. Until next time, stay curious, stay kind, and keep learning. This is Rolando ASISTEN Jr. signing off from the Math Avenue podcast.